Good night, everyone. So I'm here today to continue. Okay, lesson for week number 13. Okay, so it is called as moment distribution method. Okay, moment distribution method. So are you from diploma intake or matriculation?
Polytechnic.
Polytechnic. Any others? Yang daripada matrikulasi ada? Ya? Ada tak yang before this tak pernah lagi belajar langsung tentang this topic, moment distribution method? Because yang mana yang from polytechnic, from diploma, actually you have learned this, right?
Ya.
Okay, ada tak yang from matrix? Tak ada? No one from matrix. So means that semua dah ada basic lah. Kalau semua from diploma intake, from polytechnic, okay, I believe you dah ada basic lah. Okay, so because you have another 2 weeks only, this week and next week, and actually coverage this topic is quite heavy juga. Okay, and of course you need to you need to focus on this because this topic will be tested in your final assessment. Okay, so tak apa. So I have actually yang tadi kan saya dah bagi link my YouTube channel yang mana I have actually put all the example all video lecture. Actually, moment distribution method ni in Penang, actually also the last chapter. Tapi for this semester, I move to the first chapter. So I covers a lot. Okay, it is about four weeks. Okay, 4 weeks. So banyaklah yang saya cover. And then saya memang selalu buat extra session jugalah. So dalam tu ada banyak video yang you boleh tengok. Okay, of course, sesi tonight kita lebih kepada introduction untuk revise back what you have learned previously. Okay, what you have learned previously. And okay, ada banyak video jugalah, in YouTube channel because this is one of the famous topic in the world. We are going to analyze indeterminate beam and frames using moment distribution method. We will calculate member and moment. Okay, so this topic is actually relates with the topic name slope deflection method, and some of the concept actually kalau from the textbook tu you kena baca dua-dua lah. You kena baca slope concept, not the solution tapi konsep-konsep yang mana yang kita apply in moment distribution method. Konsep-konsep tu, some konsep dia dah explain under slope deflection method. So untuk understand more, you kena baca juga teori-teori yang mana relate dengan dengan moment distribution method. Sebabnya these two topics, slope deflection method and moment distribution method ni, okay, dia different topic tapi analyzing the same output. And the main output for moment distribution method is the member and moment. Okay, so this is the learning outcome. So okay, so for the first session I will try to cover all this tapi kita go through very fast because saya tak akan buat example one by one tonight. Okay, so example tu as I mentioned just now, you boleh tengok balik video-video yang saya dah letak link pada Telegram yang saya share last week tu, Telegram, as well as dalam YouTube, my YouTube channel tadilah. Okay, so number one, so under this topic, what you should understand what you will learn is actually the final objective is to calculate fixed member and moment. Member and moment. And in order to do that, we have to go through some procedure. Okay, including member stiffness and distribution factor. Member stiffness and distribution factor. So this is two important key lah. Member stiffness and distribution factor. Member stiffness, the symbol is K. Member stiffness, the symbol is K, tapi dia bukan lagi stiffness matrix method. Okay, so K that we calculate under moment distribution method is a single value. Is a single value, K for element. Okay, it will be K for element number 1, K for member AB, K for member BC, and so on. Single value using simple formula. Okay, small letter. Okay, K. And distribution factor is actually we get from K. Distribution factor. What is distribution factor? Distribution factor will be K divided by total K. And we will use distribution factor. We will use distribution factor whenever we want to distribute moment in the table. So we will calculate member and moment using table, in the table form. In the table form, and the process will be do repetitively. Okay, dia proses yang berulang-ulang dalam table tu. So once you kena buat one cycle and then repeat second cycle and then repeat third cycle and then repeat fourth cycle, repeat until the moment in the table reaches zero value. Okay, and in the table, what most important is distribution factor. And distribution factor we get from member stiffness, K. Okay, and we have another term called carryover factor. Carryover factor, we do not calculate carryover factor, but we use carryover factor. We do not calculate, but we use carryover factor. There are two values of carryover factor, 0 and 0.5, based on far end condition. Based on far end condition. And we will use this factor in the table as well, but we do not calculate carryover factor. Okay. And stiffness modification factor tu untuk some case lah, some cases, because when we have to consider end condition depending on the support, fixed support, roller support, pin support. So we need to consider that. Tapi simple je lah, the formula, the difference between pin end, between fixed end, it is actually quite simple. Okay, number 2, apply fixed end moment due to external loading and support settlement. sorry, actually saya batuk sikit. Okay, fixed end moment. Fixed end moment ni, okay, fixed end moment ni, I have passed to you, if I pass to you my notes for beam, if not nanti saya letak, sebab fixed end moment ni actually I discuss quite detail under stiffness method under beam topic. So kalau you free, you boleh tengok balik mana-mana video saya tu, video saya dekat my YouTube channel yang bincang on stiffness method for beam. Because under stiffness method for beam, saya ada bincang quite detail about fixed end moment. Fixed end moment. Okay, so fixed end moment ni is actually the first member and moment in the table. Okay, kita nak calculate objektif kita, output kita, main output. Main output is member and moment. Member and moment. So ada term-term yang kita kena understand lah what is actually member and moment. Member and moment ni refers to, for example, kalau kita ada beam like this is a continuous beam. We have A, B, C and D. Okay, ada loading, for example, like this. Okay, so by looking at this beam, ini beam by looking at this beam, okay, we know that there are 3 members. Or 3 element. 3 members. We have member AB, we have member BC, we have member CD. 3 element lah, 3 members. And each member Okay, each member, kalau kita tengok one by one member, okay, konsep ni lah yang saya kata you kena tengok dalam slope diffraction method. Dia tak explain lagi, dia tak repeat lagi the explanation in moment distribution method chapter in the textbook. Okay. Okay, this is member AB. This is member BC. This is member CD. So member and moment refers to moment at each end for each member. Moment at each end for each member. And at the beginning of the process, okay, we assume all positive. Positive clockwise. The sign convention used for this chapter is clockwise positive. This is the first assumption. So the red color ni represent member and moment, which will be the output from the table. Member and moment. Member, it is member and moment. So nanti lepas dah kita buat distribution, from the table, we will get the right value with the right sign. Okay, but first assumption, okay, when the question, okay, when the beam like this is given to you, the question is calculate member and moment, or calculate bending moment, or calculate internal moment. Okay, all terms, okay, different terms, but represent same thing. Member and moment, internal moment, bending moment, so will be the same. Okay, member and moment. So in order to calculate member and moment using moment distribution method, okay, we have the first member and moment in the table, which is actually the fixed end moment. So fixed end moment ni, or FEM, will be the first. Okay, this one is first member and moment in the table. First member and moment. First and moment in the table. That is why dekat sini, okay, you have to understand that fixed and moment ni ada two category. Okay, fixed and moment ni ada two category. One is due to external loading. This is number one. Two is support settlement. Two is support settlement. Okay? Ada dua. Okay, so under moment distribution method, dia cover two type of structure. Beam and frame. Okay, so under beam ni pecah dua ni. Okay, under frame pun pecah dua, yang ni number one ni number two. Under beam also pecah dua, one and two. Okay, one is without delta, support settlement, with delta. With delta in beam refers to support settlement. Yang ni support settlement. Ini dia punya coverage. Okay, and frame we have two types. We have frame without side sway. Okay, frame without side sway, without delta. Yang ni frame without delta. Sama macam atas, tapi delta for beam and delta for frame represent different things. Without delta and frame with side sway with delta. So this delta refers to, delta in frame refers to side sway. Refers to side sway. Okay, this is the coverage. The coverage. So basically, kalau untuk beam without delta, we will have one table. Beam with support settlement, beam without support settlement, one table only. Beam with support settlement, we can solve using one table or two table. Both can be done. Okay, we have frame without side sway. Frame without side sway, we can analyze using one moment distribution table. And frame with side sway, we have to have two moment distribution table. We cannot combine like beam. Okay, this is about the coverage lah. Okay, so yang ni nanti you read on your own about the principle only. Okay, the history and the principle ni. Okay, sign convention as I mentioned just now, we use clockwise positive, clockwise act on member, act on member, clockwise moment act on member. So the diagram that I have shown to you previously means that at the beginning of the analysis, okay, when you are given a beam like this, an indeterminate beam, a continuous beam, so the question is calculate member and moment. So firstly, you have to set in your mind the member and moment refers to this all 6 rate and moment. Clockwise that act on member and moment. Member and moment. Clockwise moment that act on the member are considered positive. Okay, that is the first assumption, not the answer. That is the assumption before we start analysis. Okay, so next term, okay, the fixed end moment. The fixed end moment, you actually can refer to the same appendix with stiffness method appendix. Okay, appendix page 3. And fixed end moment, kalau under stiffness method tu, we also call as equivalent element nodal forces. Equivalent element nodal forces is fixed end moment. Okay, so this is example lah. This is example how to calculate fixed end moment. So to calculate fixed end moment, we have to assume all members are fixed. That's why we apply fixed end moment. So kita boleh assume semua member dalam structure yang kita dapat tu, continuous beam pecah jadi AB, BC, CD. So each AB, BC, CD tu semua tu kita boleh assume both end fixed. Boleh assume dia both end fixed. And what most important is fixed end moment, what you have to understand is fixed end moment is behavior. Fixed end moment is behavior. Kalau tadi member and moment ni is member and moment is actually okay, the direction of member and moment, the sign based on sign convention tu, yang tu assumption. But fixed end moment, the direction that we get from fixed end moment diagram is not assumption. Yang ni bukan assumption. Yang atas tadi tu because of sign convention. Sign convention yang kita decide untuk pakai is clockwise positive. So that's why direction tadi yang you nampak macam tu. Because ada buku lain yang pakai counter clockwise positive. Ada satu buku, dia punya author dia Aslam Kasim Ali, dia pakai counter clockwise positive. Jadi kalau you refer yang nota tu, dia punya sign dalam analisis semua terbalik. Okay? Anyway, you akan dapat the same answer lah. The same answer at the end of analysis. But for fixed end moment, sign yang you nampak kat sini, yang ni bukan assumption. This is behavior. Fixed end moment, the sign convention that we get from fixed end moment tu is behavior. Okay, behavior. Dia sebab apa tahu? Dia akan behave. Okay, you just remember one thing. Okay, so this is beam. Ada fix kat sini because assumption yang kita buat tu lah, both end are fixed. So when this beam is loaded by 800 Newton, what happened to the beam? The beam will deflect. Dia deflect lah, dia deflect. The beam will deflect. And deflection ni we cannot see. Okay, the deflection is very small. Normally we cannot see lah. Kecuali yang memang nampak real lah kan. Contoh macam you ada rak buku tu. You letak buku penuh kat rak tu, you nampak dia punya bending. Okay, yang tu yang very clear lah. Normally the deflection kita tak boleh identify pakai mata lah. Okay, so dia akan deflect due to loading. And then the system structure ni must be the structure must be equilibrium. Structure must be equilibrium internally and externally. Internally and externally. Yang ni kita dah take out as element. Dia jadi internal lah. Okay. So must be balanced. Okay. Must be in equilibrium at all time. Jadi bila ada support, so dia akan ada reaction untuk counter back. Sebab bila dia bend macam ni, okay, due to loading 800 Newton, fixed end moment akan react in the other way round, so that the bend beam will move to straight position. Bila kita nak apply fixed end moment, we have to make sure that bila kita apply saja moment tu, kita kena apply dalam arah untuk kita jadikan this bend beam go back to its original position, which is straight position. So arah mana yang kita nak apply? Yang ni or yang ni? So that the beam will move back to its original position. The purple or the blue? Purple or blue? Purple or blue? It must be purple. It must be purple. It must be purple. So fixed end moment, just remember like that. So look at the bending occur, the deflection occur due to loading, and then moment is always counter back. So counter back so that it will move back to its original position. Okay. So this is about fixed end moment, and of course there are some condition. Ada yang point load at the center. Okay. Kita boleh fokus yang ni only this. Okay. Actually fixed end moment ni pun ada two condition. Anyway, we can solve all types of problem by using the formula in the first column. So dua-dua kolom ni dibezakan dengan end condition. Ini nama dia end condition ni. End condition. Okay, end condition. Okay, apa end ni? End dekat kolom number 2 tu. Yang ni nama dia far end roller or pin. Okay, yang ni nama dia far end fix. Okay, far end fix. Okay, actually boleh pakai dua-dua lah bila condition dia memang end roller and fix lah. Tapi kalau let's say beam to end dia, end pin and dia end roller, kita still boleh pakai far end fix untuk solve the problem. Okay, so dia ada point load at the center, dia ada point load not at the center, ada combination of more than one point load. Okay, ada UDL. Lepas tu ada lagi triangular load. Okay, basically yang kita selalu jumpa, this is number 1. Number 2, yang selalu jumpa Number 1, number 2, number 3, and number 4. Ini yang 4 yang selalu jumpa lah dalam soalan. Okay, and the last one ni is for support settlement as well as side sway for frame. The same concept. Okay. Okay, saya terus introduce sekali yang FEM due to side sway ni, due to support settlement ni, due to delta. Yang ni, always remember that fixed end moment ni dia behavior. Fixed end moment behavior. So kalau due to delta, dia akan dapat macam ni. Means that beam ni, okay, beam A, B, C, D. Okay, dalam soalan, mention about support settlement at B. 30 mm. 30 mm. So B settle from original position to new position. This is B prime. Okay, so what happened? What happened? We will have frame after settlement like this. Okay, when this condition occur, so yang ni we have to calculate FEM due to support settlement. Due to support settlement. Yang tadi due to loading. PW, semua tu loading. But when it comes to support settlement, okay, support settlement, the diagram due to support settlement will be like this. Okay, for example, let's say delta B is equal to 30 mm. Support B is settled. Support B is settled. So we have the diagram like this. So AB and BC will have fixed end moment. CD tak remain the same lah, tak bergerak lah, remain the same. Okay, so we will have to calculate FEM. We will have to calculate FEM for AB and FEM for BC. So sama juga bila kita nak letak sign for FEM due to delta ni, this is delta. This is delta B. Okay, we have to look at the beam after settle. Okay, beam macam ni. After settlement occur for AB. And always remember that the beam, so sini ada support lah, fix tu. Okay, the moment will push back will push the new beam, the new position of beam to move back to its original position. So in this case for AB, kita nak apply moment clockwise ke anti-clockwise? In this case, so that it will move back to its original position. Original is horizontal. Original is horizontal. We want to apply moment. We want to apply moment to push the beam to move back to its original position. Kat arah mana kita nak apply? Clockwise? Ya?
Clockwise.
Clockwise? Bukan jadi vertikal ke macam ni? Don't forget kita nak jadikan dia horizontal. So what should be the direction? Clockwise or anti-clockwise? Anti-clockwise kan? Okay, it should be kita nak jadikan dia straight balik. Straight means horizontal. Beam punya original position is always horizontal. So to move back to its original position, we have to apply moment to counter back. Okay, to counter back. So untuk jadikan this incline AB ni to move back to original position, we have to apply negative FEM. Negative FEM. So yang ni behavior yang kita mesti faham bila kita nak apply. Okay, bila kita nak apply support settlement, kita nak solve support settlement, kita kena apply this. Okay, apply this behavior. Okay, means that FEM yang kita nak calculate tu, FEM yang kita nak calculate for AB, which is equal to FEM BA, it should be negative. It should be negative. It cannot be positive. Sebab kalau kita apply positive, dia represent different behavior. Different behavior. Kalau kita apply positive, positive means for BC. BC after settlement, dia macam ni. BC after settlement, clockwise or anti-clockwise? Kalau for BC. After settlement, we get like this. Kita tengok from ni Okay, from this main diagram. So BC, okay, is this. This is BC. So we have to apply moment at B and C. It is fixed end moment. So which direction? Moment. The fixed end moment. Clockwise or clockwise? It is clockwise.
Clockwise.
Okay, it is clockwise. So apply moment clockwise. So when we want to calculate FEM for BC, it is also equal to FEM CB. This must be positive value. Positive value. Okay, nanti saya terang lagi in detail macam mana kita nak calculate this easily. Okay, kita nak understand, nak calculate this easily in the table nanti. Okay, so we move to member stiffness factor yang tadi K kecil tu. Okay, K kecil, K besar tak apa, doesn't matter. K member stiffness factor. So always remember that K ni belong to member. K belong to element. K not belong to joint. They belong to member. That is why masa kita buat stiffness method hari tu, okay, we call K as element global stiffness matrices. Because K ni memang belong to member. Okay. So we have to consider, actually yang ni yang basic. Yang basic ni is when N dia fix lah. And the fix it is K is equal to 4 EI over L. K is equal to 4 EI over L. So kita apply je formula ni untuk calculate K for each element whenever we have macam ni lah. Macam yang tadi ni. So we have A, sini B, sini C, sini D. So we have to calculate K for AB. We have to calculate K for BC. We have to calculate K for CD. And if we have this condition, okay, we have to use K is equal to 4 EI over L for all element. 4 EI over L. This is also 4 EI over L. Okay, N condition, dia sebut kat sini N. Dia sebut kat sini N5 far end. Far end ni refers to end yang paling hujung. Far end ni refers to end yang paling hujung. Means that end A and end D. Itu far end. Itu far end. Far end ni refers to yang paling hujung. Because internal B and C tu internal always fixed. Internal B and C ni always fixed. Internal always assume as fixed. So internal automatically kita pakai 4EI over L internal. So far end condition, far end fix refers to end A and end D. And for this case, A end dia fix, D end dia fix. So semua kita pakai 4EI over L. And we have another one formula. Another formula. Okay, it is K is equal to 3EI over L. 3EI over L yang ni for pin and roller. Pin and roller. So bila nak pakai yang tu? Whenever we have, for example, macam ni.
Doktor mute.
Okay, again. Okay, yang ni. So we have two condition of beam. So yang atas ni, far end fix refers to A refers to D. Internal fix. Yang bawah, we have roller at D. We have roller at D. Okay, A ni far end fix. So we use 4EI over L. Internal always fix. Yang ni internal always fix. And then bila kita nak calculate K for CD, we have to refer to far end D. Far end D is roller. So kat sini kita kena pakai 3EI over L. Okay, 3EI over L. So kalau ada satu lagi, for example, if we have sini pin, roller. Yang ni nak pakai apa formula? A, B, C, D. Okay, A, B nak pakai formula apa? A, B? 3EI or 4EI? For A, B.
3EI.
Okay, it is 3EI over L. B, C?
4EI over L.
Yeah, 4EI. C, D?
3EI over L.
Yeah, 3EI over L. Okay. After that, joint stiffness factor ni is just for the purpose of getting distribution factor. Okay. So, untuk calculate distribution factor, kita kena find total K. Total K. Maksudnya kita gabung K tu. So, bila nak pakai, kita akan get total K, and then we calculate distribution factor. Distribution factor is K divided by total K. K divided by total K. So, always remember, kita akan ada K for each element. Sebab itulah dalam ni, dalam ni. Okay, ni example only. Dia bagi value. Normally, K ni you have to calculate. Dia tak akan bagi value like this. Okay. So, remember that K is for element. So, that's why this is member AD. Member AD. So, K dia 1000. Member AB, K dia 4000. Member AC, K dia 5000. And use formula DF is equal to K divided by total K. Okay, number of DF ni equivalent to number of member and moment. Number of distribution factor that we need to calculate. Okay, kalau macam beam yang atas ni tadi, okay, beam ni, semua beam ni ada 6 member and moment. Sebab apa ada 6? Sebab ada 3 elemen. Satu elemen tu, satu member dia ada 2 N. Satu member ada 2 N. Okay, so dia ada 6 N moment. 6 member and moment. So, distribution factor must be the same. So, kalau ada 6 member and moment, distribution factor must be 6 as well. Okay, distribution factor. So, distribution factor ni, okay, how we identify member and moment? Kita sebut member and moment ni macam ni. Kita ada AB, so we have MAB, MBA. MAB, MBA. Macam ni lah, at the beginning, dia macam tu lah, in the beginning of the process. MAB, MBA. Ini dia. Okay, for AB. And then we have member BC. Member BC. Okay, this is the sign convention based on the sign convention. So yang ni MBC, MCB. MBC, MCB. And then we have member CD. Member CD, we have MCD, MDC. MCD, MDC. So we have in total like this. So we will have distribution factor like this. DF AB, DF BA. We will have DF BC, DF CB. We have DF CD, DF DC. Okay, so we will calculate distribution factor from stiffness factor. K tadi tu. K. Even though K tu for element, but distribution factor ni kena calculate 6 value like this. Okay, 6 value like this. Kita tengok lagi. Yang ni. Yang ni cara simple untuk kita calculate kita calculate distribution factor lah. For example, if we want to calculate K for AD, bukan K. DF for AD, DF for AC, DF for AB. Okay, kita tengok dulu ni. Distribution factor. If a moment F is applied to fix connected joint. Okay, tak apa. Statement ni okey, tak apa. Saya tak bagi tahu yang okay. Okay, distribution factor ni ada another 2 things that you need to remember. Distribution factor is 0 for N fixed. And distribution factor is equal to 1 for N pin or roller. Jadi kena ingat. Okay, it means that dalam case yang ni, distribution factor untuk sini 0, 0, 0. Distribution factor. So what we calculate here is DF AB, DF AC, DF AD. Because in this case there are 3 elements as well. dalam case ni kan dia ada 3 elemen juga. 3 elemen member A, AB, member AB, member AC, member AD. 3 elemen as well. So bila ada 3 elemen, ada 6 end moment. Ada 6 end moment. So 6 end moment. This is based on sign convention. So there will be 6 distribution factor. 6 distribution factor. And B, C, and D, these 3 are fixed end. Fixed end. So distribution factor for B, C, and D will be 0. So yang ni, DF ni 0. DF ni pun 0. DF ni pun 0. Okay. So yang kita nak calculate DF AD, DF AB dengan DF AC. Okay, yang ni je yang kita nak calculate, yang 3 tu. So yang 3 tu, yang ni tambah satu lagi. Yang ni tambah satu lagi rigid joint. Kalau frame lah. So ini untuk frame. Macam ni lah rigid joint. So total tiga-tiga ni. Total DFAB, DFAC and DFAD must equal to 1. Total. Sama ada dia total ke ataupun end pin and roller tu paling hujung, dia akan jadi equivalent to 1. Okay. So dapat macam ni lah. Okay, DFAB, AB is 4,000 divided by 10,000 dapat 0.4 and then 0.5 and then 0.1. Total this equal to 1. Equal to 1. So this is basic calculation of distribution factor. So quite straightforward lah, simple sangat yang ni. Okay, lepas tu kat sini dia tunjuk teori. Theory about the moment that we distribute. Theory about the moment that we distribute. Okay, let's say ada satu joint moment applied at A. So we have to distribute to AB, AC and AD. So how we distribute? We have to use joint moment times with the distribution factor. So kita distribute. We get this. Total ni takkan dapat 2,000 balik but in opposite direction. So that is the basic lah. The basic of moment distribution. Okay. So carry over, as I mentioned, carry over ni we do not calculate carry over factor, but we use carry over in the table. And for far and fixed, the factor is 0.5, and far and pin roller, the factor is 0. The factor is 0. So we go to procedure for beam analysis first. Okay, the procedure. Tak payah hafal pun procedure ni because nanti kita buat dalam table, you akan nampak lah how we calculate the end moment. Okay, most importantly in the table we must have distribution factor. Distribution factor, number of distribution factor sama dengan member end moment, sama column. Lepas tu distribution factor for end fix 0, end pin roller 1 including rigid joint. Lepas tu fixed end moment is first member end moment in the table. Yang ni tiga benda ni kena ingat. Lepas tu carry over factor lah, carry over factor. Okay. So yang note nanti baca. Okay, so this is the example based on chapter 12.1 dalam buku teks Hibler. Okay, determine internal moment. As I mentioned, internal moment, member end moment, bending moment, semua ni refers to the same thing. Okay, so yang ni macam example yang saya sketch tadi lah. So in this case, A dengan D fix. A and D fix. So BC ada UDL. Lepas tu ada point load at the center. Point load at the center. So remember, apa yang important? Important before kita nak calculate end moment, distribution factor and fixed end moment as the first member end moment in the table. In this case, there is no support settlement. Ingat dua benda ni. Apa yang important? Number one, distribution factor. Number two, fixed end moment. Ini je yang kita nak. Okay. Untuk kita masukkan in the table and then kita start distribute moment. Okay. Distribution factor. Distribution factor, fixed end moment. And fixed end moment is the first member end moment in the table. Distribution factor, in order to get distribution factor, we have to calculate stiffness factor first, member stiffness factor. We use we use formula 4EI over L and 3EI over L depending on far end condition. Okay, lepas tu we get distribution factor by using formula K divided by total K. Lepas tu fixed end moment. Fixed end moment ada two types. One is due to external loading. Another one is due to delta. So in this case, there is no support settlement. So we can calculate the internal moment using one table only. Okay. So in this case, we have 4EI over L. 4EI over L. Okay, 4EI over L. This is 4EI over L. This is 4EI over L. This is also 4EI over L. Okay, so we can simple sangat kan? Kita dapatlah all this value. And fixed end moment again kena tengok pada loading tu. So dia akan bend like this. This is also bend like this. So moment in this case like this. And based on sign convention that we have set at the early of the process, sign convention for this method, sign convention kita clockwise positive. So apa saja yang opposite dengan clockwise dia akan jadi negatif lah. So yang ni akan jadi negatif dalam table, positif dalam table, negative and positive. Okay, so calculate all this. So we calculate all this. Guna formula, refer formula only, calculate all this. So the gap distribution factor. Distribution factor ni nanti kalau nak tengok in detail macam mana kita buat ni, tengok video-video saya. Okay, nanti saya share link, direct link untuk you refer. Example ni memang saya dah buat banyak kali. Every sem pun saya buat. Yang awal sem hari tu pun saya dah buat untuk 5 to 1. Okay. So distribution factor and then fixed end moment. Okay. So dapat yang ni, we put into the table. Okay, this is moment distribution table. Okay, since we have 6 member end moment, to be determined. So we have to have 6 column, AB, BA, continue with BC, CB, continue with CD, DC. Okay, so we start with distribution factor. So since A and A tu is fixed and D also fixed, we put 0, 0. And internal and rigid joint. Internal dengan rigid joint. Rigid joint ni untuk frame lah. Okay, internal and rigid joint, as well as pin dengan roller kalau dekat hujung, total must be 1. Sebab tu kat sini, total ni dapat 1. Yang ni 0 sebab dia end fix. Because end fix ni, dia divide by infinity. So, dia dapat 0. Okay. So, ni distribution factor. Lepas tu, we have to put the first member and moment in the table. We have to put member and moment in the table. And member and moment in the table is come from FEM. Yang tadilah negatif, positif, negatif, positif. Okay, lepas tu kita kena start distribution. So dalam table ni, macam mana kita nak faham? Yang ni lah yang saya kata you kena refer balik satu konsep dan juga diagram yang ada explanation dalam slope deflection method. Diagram tu. Okay, you have to understand that beside, okay, we have this. So sorry, tak sihat. Semalam demam ni. Okay. So this is the question. This is the question. So we have A, B, sini B, C and D. Okay. Objektif kita nak calculate member and moment. Bila kita draw the free body diagram of element. So yang ni lah dia yang tadi kita mention as member and moment. But beside member, we have join. We have join. Satu lagi adalah join. Kat sini. Kita ada join sini. Sini fix lah. So we have member, we have join. So ini A, ini join A, ini join B, ini join C, ini join D. Okay. Refer back to konsep tadi yang dalam frame tadi. This 2000 ni. This 2000 ni refers to join moment. Ni. Join. Join moment. So this 2000 ni yang kita kali dengan distribution factor. Okay, so remember that fixed and moment is member and moment. The first member and moment in the table. But actually, the moment that we distribute is join moment. So beside member and moment, we have, mana diagram tadi? Ni. Okay, beside member and moment, we have another moment, which is called as join moment. And join moment is always opposite with member and moment. So at A we have join join A and moment at join A opposite. Okay, at B we have join moment which is opposite. Letak je yang arah opposite tu. Join moment always opposite with member and moment. That is the fact. We will analyze, we will calculate member and moment. Okay, by using join moment. We distribute join moment. We get member and moment from join moment. Okay. So what we actually do is when we calculate fixed and moment for BC tadi, kita dapat 1 negative, 1 positive. 1 negative, 1 positive. Kita dapat sini 1 negative, 1 in the table. Kita dapat sini 1 negative, 1 positive. 1 negative, 1 positive. When we distribute moment, okay, this is join. Okay, join moment that we distribute is join moment, not member and moment. So, kalau you dah pernah belajar before this, you mesti ingat dia punya step apa. Okay, kita totalkan moment kali dengan distribution factor, tukar sign, letak dekat situ. 120. Letak dekat situ 120. Actually, apa yang kita distribute is positive 240. Yang kita distribute is positive 240. Sebab join moment is positive 240. Dekat sini. Dekat B tu. So at B dekat sini 240 is the joint moment. 240 is the joint moment, not negative 240. Joint moment is opposite with member and moment. Ikutlah macam mana cara you nak ingat. Tetapi the concept is like that. Okay, the concept is like that. So, total yang kita dapat from this, it is 0 plus negative 240. 0 plus negative 240, we get negative 240. Negative 240 tu bukan lagi joint moment. Joint moment is positive 240. So, that positive 240, we times with factor 0.5. We times with factor 0.5, we get positive 120. We get positive 120. So because the factor is equal, so we get 120, 120. And then total ni must equal to 0. Because the system must be in equilibrium. Joint, yang ni total pada joint. Total must be equal to 0. Dia reflect pada yang diagram tadi juga. Yang ni tadi. Between joint moment, this is joint moment, dengan moment yang kita distribute, direction opposite. Because, okay, the joint must be in equilibrium. So, yang dalam table tu, that is the process. That is the process at distribution level. At distribution level. So, we continue to join C. We continue to join C. So, totalkan dulu. Okay, totalkan yang ni. Total we get negative 10. Okay, total we get negative 10. Okay, when we change sign because of opposite condition of joint moment. So, 10 is the joint moment. That is why we get 4 and 6. 4 and 6. Okay, and then last joint is D. Since the factor is 0, so we don't have to calculate. We don't have to put anything. Okay, next step is, okay, try to understand yang distribution ni dulu. Distribution. Lepas tu kita move to the next step. Kita move to next step. Next step is carry over. Next step is carry over. Carry over. Okay, we have to carry over to opposite joint. Okay, it must cross boundary. It must cross boundary. Yang ni, cross boundary. Cross boundary. Dia macam ni. Dia cross boundary. Semua ni dia cross. Bila kita nak carry over. Okay, carry over. Cross boundary. We have to carry over using the factor. And the factor for N fix. Semua ni N fix lah. Sebab A dia fix, D fix, internal semua fix. Internal semua fix. Internal semua fix. Okay, internal all fix. A dengan D, far N fix. So, kita pakai semua 0.5. So, that is why kita dapat yang ni 60. 60. And then we get 60 yang ni. Yang 120 ni. 120 ni. We get 60. We put here. Because it must cross boundary. Cross boundary. And then we get 4. 4 kan? 4 ni. Cross boundary. 2. And 6. Cross. Dia time with factor equal to 3. Okay. Okay. Distribution carry over. Distribution carry over ni represent one cycle. Yang ni represent one cycle. Cycle number 1. So, repeat the process again and again and again until the moment reaches 0. Okay, when you meet 0.0 something, okay, you may stop distribution. And normally you, not normally lah, you must stop at distribution. You jangan stop dekat carry over because kalau you stop dekat carry over, you tak boleh balancekan moment. So stop mesti dekat carry over. Even though cycle dia kan distribution carry over. Lepas tu dah last tu continue dengan last distribution. Lepas tu stop. Bila stop, you have to total all the moment. Start from the first moment in the table. Start from the first moment in the table, which is start from FEM lah. Start from FEM. So total semua ni, then you will get the end moment. So this is member end moment. Okay, this is member end moment. And ikut konsep yang explain dalam slope deflection method. So this is MBA, MBC, total equal 0. That's why we got 1 negative, 1 positive. And then we have MCB, MCD, total equal to 0 plus, okay, equal to 0. So yang ni sebab dia N fix ada moment at A and at D. So ni moment at NA, moment at ND. And from this actually we can actually sketch the bending moment diagram, because this is bending moment value. So by using moment distribution method, we can actually get the bending moment diagram easily. Okay, not without writing moment equation, substituting x value, but we can get the bending moment value, and we can sketch the value directly, okay, from the moment that we get from the table. So from the moment that we get, okay, just identify the moment direction. This is positive moment. This is positive moment. This is also positive. This is negative moment. This one is positive moment. This one is negative moment. This one is positive moment. Okay. So for the bending moment diagram, okay, kat sini for the bending moment diagram, positive. Okay, positive. Correct, positive. Okay, for AB, because the moment is like this and like this, so the bending moment diagram will be this. The bending moment diagram for A, B. And for BC, we have negative, positive, this and this. And since it is UDL, so the moment that we get point like this, and it is curved. And this point can only be determined using shear force diagram. Use shear force diagram only. Okay, and for the last one, for member CD, okay, we get direction negative and positive, like this, one negative, one positive, means that in the bending moment diagram, we get like this. And since it is point load, so this will be the diagram. And again, this point, we use shear force diagram only to determine the maximum moment for member CD. So when we combine, we will get the bending moment diagram like this. Okay, so this example, saya ada banyak video yang saya explain the same. Okay, saya explain macam mana nak dapat the intersection, the moment at the intersection, semua saya dah explain dalam my video in my YouTube channel. Nanti saya share dia punya link, and you boleh cari jugalah. Okay, cari link yang mana saya dah explain all about this. Okay, so I think I want to stop the session, okay, until this example only. Okay, insyaAllah in the next session, okay, next session you will be continue dengan face-to-face session kan? Face-to-face session, nanti saya check balik lah dengan your face-to-face lecturer, kat mana saya nak continue. Okay, if you need extra session, you just tell me. If you need extra session in order to understand more about moment distribution method, you boleh inform nanti saya akan buat insyaAllah. Tapi after Selasa lah, because Selasa tu ada event, as I mentioned lah, event tu after Selasa insyaAllah will be okay. Okay, any question before we end this session?
Doktor, attendance buka lagi lah terlepas nak isi.
Tak, saya tak buat pun tadi. So saya ingat saya akan buat attendance ikut jadual, boleh? So you masuk ikut slot jadual yang you isi.
Kira esok ah.
Esok.
Okay.
Okay, so saya akan isi macam ikut jadual, nanti you masuk dah isi lah. Okay. Ada lagi?
Ada saya.
Any question regarding this example?
Ada.
Ya.
MDM ni dia boleh apply kepada certain jumlah span juga ke tiga ataupun 2 je?
Tak, boleh je. Can be more than 3. Cuma bila lagi panjang span tu, lagi panjang dia punya proses tu. Sebab kalau you ada tu, for example yang ni 3 span kan. 3 span basically kalau you tengok kan, ada how many cycle? Ini ikut table ni lah. 1, 2, 3, 4, 5. 5, 6 macam tu lah. Kalau 3 span. Kalau 2 span, basically 1 or 2 times. 2 cycle only. You dah kena stop. Because bila lagi sikit span, lagi sikit you punya cycle. So, lagi banyak span, lagi panjang you punya cycle. So, kalau dalam exam, dalam test tu memang we normally limit to 3. Okay?
Okay, madam.
Okay, any more? Sepatutnya saya nak, itulah macam kalau ikut sini kan, kena cover untuk 1 minggu. Lepas tu sambung frame untuk 1 minggu lagi kan. Ada 2 minggu lagi je kan. Okay. So saya akan inform your face to face lecturer untuk continue yang settlement tadi. Actually settlement pun quite simple juga, cuma you tambah formula je lah. Dia simple ya. Kalau beam analysis memang simple. So yang complicated tu adalah frame. Complicated is frame. So yang ni sebenarnya you boleh go through je. Yang ni example yang 2 span tadi. Kita just 2 span kan. 2 span, yang ni A fix, B ni roller. B ni roller, so 2 span. So 2 span, tengok dia punya table. Macam ni. Only. Kan, lagi sikit span. Kalau minimum 2 span, tak ada 1 span kan. Minimum 2 span, dia macam ni je cycle dia. Okay, yang ni kalau 2 span. So 3 span normally 5, 6 macam tu lah you akan dapat. Okay, and saya always advise student lah untuk bila you dah dapat end moment ni, you terus practice draw diagram. Because MDM ni is very important bila you buat design lah. Buat design kan, from design tu you need to have the bending moment in order to identify kat mana crack dia semua kan. So that's why kalau as engineer ni, yang engineer yang memang dekat industri, memang dia still pakai MDM ni untuk identify kat mana crack, especially untuk design purpose lah. Okay. So ini sama je. Dia quite easy, MDM ni quite easy because you just need to follow the procedure as I mentioned tadi. So ingat dua benda tu je, distribution factor and fixed end moment. Fixed end moment, kalau ada settlement, consider settlement. So tambah je dua-dua nilai tu. Okay, tambah. So yang ni case yang ada banyak loading lah, banyak loading. So tengok formula je dan boleh calculate lah. So quite simple lah. Okay, yang tu je kot, tak banyak sangat. So yang ni settlement. Okay, so settlement ni we will cover in your next class. Okay, ada lagi soalan? Before we end session, ada lagi? Okay. Okay, so this is quite important because your assessment tu, your final assessment kan, will be taking from topic number 1 and topic number 4. So yang ni lah, even though dia 2 weeks only, tapi you have to know quite a lot lah, quite a lot. So for those yang mana yang come from diploma, dah pernah ambil dah pernah belajar this one, so you need to revise back lah. Okay, you akan tak perlu nak faham banyak sangat lah kan, sebab you dah pernah pakai dulu, pernah guna dulu. And kalau ada yang from matriculation, kalau rasa macam you need more session, so just tell me. Okay, boleh message saya dekat Teams chat lah as usual. So that's all for this session. So thank you for joining. So esok saya akan set you future, so isi macam biasa. Okay, so thank you. Tengoklah kalau Selasa ni, kalau sempat kita boleh continue. If ada request lah. Okay, so thank you very much.